In this presentation, we'll focus in on CAMWORKS 3-axis VoluMill. VoluMill can help companies reduce cycle time by 80% or more, increase production by as much as 400%, and increase tool life by 500% or more. VoluMill uses the latest rough milling technology to create ideal cutting conditions on any CNC milling machine, from the oldest, slowest machine to the latest high-speed CNC machines. The part on the right took roughly 10 minutes to rough machine using conventional feeds and speeds, but using VoluMill, the cycle time was reduced to just 2 minutes. This means we were able to machine 5 parts in the same time it was taking to rough machine a single part. That's an increase in production of 400%. Without buying a new machine or tool or any other expense. And this is based on a job that included just 10 minutes of rough machining. So now, let's take a hands-on look at CAMWORKS 3-axis VoluMill. Here's an electric motor housing that was designed using SolidWorks, and this might be manufactured out of high-temperature plastic or composite. And what I'd like to do is use this part to discuss the 3-axis VoluMill that's available for CAMWORKS. And to do that, let me switch over to a SolidWorks assembly. And here you can see in this assembly, I've designed a mold for the housing. And this only took a few minutes to design, thanks to the tools in SolidWorks. And you can see I've set it up in a vise and on a table, ready for machining. So I'm going to use CAMWORKS now to program this part, and in particular, we're going to use the 3-axis VoluMill to machine this cavity. So let me go to the CAMWORKS feature tree, and I'll begin by extracting the machinable features on the part. And the CAMWORKS automatic feature recognition very quickly recognized the 2.5-axis prismatic features on the part, including the 4 slots in the corners along with a group of 15mm holes. And it placed them all together in a group in order for me to do the machining. So now what I'd like to do is to create a multi-surface feature to machine the cavity. So I'll go here and create a multi-surface feature of all displayed. And what I'd like to do is machine the cavity first before doing any of the other machining on the part. So I'm dragging and dropping that up to the start of the process. And then I'm going to use interactive feature recognition to demonstrate the fact that you can also create operations interactively rather than just using the technology database to create operations. So here I'll create an area clearance operation for the cavity using a 16mm flat end mill. Here the operation box opens up, and now I can create that pattern. Go to the pattern tab. We will select VoluMill here. And notice as soon as I select VoluMill, it asks me about using the technology expert for the feeds and speeds. And now here I can go and select how conservative or aggressive I want to be, say OK, and VoluMill will automatically set the feeds and speeds for me based on the material. So now that we have done that, we can go back and let's go to the area clearance tab. Here you can see my maximum cut amount is set to 32mm. The flute length on this tool is 35mm. Then we're going to do a step up of 2.5mm. And I'm going to talk more about that step up here in a minute. So now that we've done that, we also want to go to the geometry tab, and we want to contain the machining of the cavity within that cavity area. So I'm going to create a contain area, and all I need to do is select one of the elements in that group that go around, that profile that goes around the cavity, and then say OK. And now I have that contain area created, so I can now preview the toolpath. And very quickly then CAMWORKS will generate the VoluMill toolpath, and you can see that toolpath there. And we can also go ahead and simulate it. So let me run simulation here, and we can see the machining. Notice how it machines all the material out of the center first, using almost the full flute length of the tool, and then it does a 2.5 millimeter step up. And I want to point that out because during the step up, VoluMill is able to greatly accelerate the feeds, and that greatly reduces the cycle time. VoluMill is one of the only adaptive roughing routines that uses MRR, or the material removal rate, or the volume of material being removed, and tracks that constantly in order to adjust the feed rate. And let's watch that once more. And I point that out because this is opposed to most other adaptive roughing routines that use a constant feed rate while doing the machining. VoluMill does not do that. It looks at the amount of material being removed, the volume of material, hence the name, and it then is able to adjust the feed rate much higher, much faster than most adaptive roughing routines. As compared to other adaptive roughing routines, you can typically still reduce the cycle time by 20 or 30% using VoluMill. So, okay, that looks great. I'm going to say okay here. Then we can go back to the CAMWORKS feature tree. We can generate the operations for the rest of the machining. And let's go ahead and generate the operations for the rest of the machining here. We'll generate the toolpaths as well. And then we can watch the simulation one more time. And you can see that being machined here. And again, you know, as compared to other adaptive roughing routines, VoluMill is superior, especially in terms of the cycle time, as a result of the fact that it tracks the volume of material being removed, and it adjusts the feed rates appropriately. Now, if I compare the design model to the machine model, you can see the stock remaining in the cavity for finishing. And I won't go ahead, I could, but I won't go ahead at the moment and do the finish machining on this cavity. There is another video you can watch. It is for the milling standard, CAMWORKS milling standard, that shows the machining of a cavity, mold cavity similar to this one. So if you want to watch that video for the finish machining, you can do that. What I'd like to do instead at the moment, let me just go ahead and save this file. And then let's close out for a minute. And now let's suppose that a design change occurs. So we're going to make a design change here. We're going to change this radius of the motor housing to 45, so we'll make it significantly smaller. We'll also change the length. So this would be for a smaller motor, for example. We'll suppose that we could determined we could use a smaller motor rather than a larger motor for this particular application. And now when I rebuild, you'll see that the housing gets significantly smaller. So we'll save that, and the designer may have made that change and saved it. Now we can go and let's suppose that the programmer goes and opens up the assembly again with that toolpaths in it. So when it opens up, you can see immediately that CAMWORKS knows the design has changed, and notice how it's already updated the cavity. And if I say OK here, then CAMWORKS will automatically rebuild the toolpaths to accommodate the design change. So you can see how quickly you can accommodate design changes and revisions using CAMWORKS. And now if I go ahead and simulate again, we'll see that the toolpath has been updated to the design change and to the smaller housing. So very quickly, you're able to accommodate design changes or revisions to the part using CAMWORKS. And once it finishes the cavity, it does the corners and then drills the holes. So that's the 3-axis VoluMill for CAMWORKS, and I want to thank you for watching. For more information, go to www.camworks.com or contact your SOLIDWORKS or CAMWORKS reseller.